Hello guys, welcome to my channel and let me introduce myself first. So my name is Arnav Koyal and I am from Triple IT Sonipat doing BTech in CSC in third year. You may say like Arnav, where are you and why the background is totally changed. So yeah, the background is changed because I'm in hostel and from tomorrow my college will be started, the fifth sem. So you may have to be used to it. Actually, in college, there may be some issues like some noise or something like that. You know about hostel things. So you have to manage a little bit, and I will try to manage all things. Like I will try to keep things the way it should be. So only our task is to do CP, and that's all. So that's from my side. Sorry. So let's start with the problem without any much further delays. Wait a second. The question is from codeforces, and the question is they are everywhere. Sergi B, the young coach of Pokemon, has found a big house which consists of n flats, ordered in a row from left to right. It is possible to each enter each flat from the street. It is possible to go out from each flat. Also, each flat is connected with the flat to the left and flat to the right. Flat number 1 is only connected with the flat number 2, and flat number n is only connected with flat number n minus 1. So what is saying? So let us suppose there are n flats, and at the ith flat you can move to I plus 1 or I minus flat. That is left or right. And but if you are at first flat, then you can only move to its adjacent, that is 2, that is to the right. And if you are at n minus 1 flat, then you can move to its left, that is n minus 2. There is exactly one Pokemon of some types in each of the flats. So in each of the flat, there is some Pokemon and have some type. Sergi B asked resident to like what he is doing to capture those Pokemons, but the residents wants that he shouldn't be visit the flat twice. So he cannot visit the flat twice at all. So Sergi B was very pleased, and now he wants to visit as few flats as possible in order to collect Pokemon. So what he wanted is to uh, move to few flats at all to catch all types of Pokemons of different types of Pokemons in an entire flat. So we have to find that number of flats minimum that we have to output. So what the like what is saying, I will explain the whiteboard. So let's move to the input, that is 10 to the power 5 is n, that is number of flats, and we have to output uh, minimum number of flats such that the second line that is contains a string s whose length is n, and it contains uppercase and lowercase letters of English alphabet. That is the ith letter equal to, that is maybe it can be uppercase or lowercase. That is the type it defines of that flat where the Pokemon live. So wait a second. Let's move to the sketch part, whiteboard. So what the question is saying so far? The question is saying, let's suppose we have some n, that is n flats, and inside that n, we have given us A, B, B, and capital B. Uh, so this is the string, that is the first flat contains A type Pokemon, and that's. So what we need to output at all? Total different uh, Pokemon so far in this entire flats. That is A, one of that, capital A, and then capital B, and then small b. So total four different types of Pokemon so far. Okay, so total four different types of Pokemon so far. There are in entire all flats, that is in n flats. Okay, so okay, we got it. But what we have to print out? So what we have to output? So A, B, B, and then B. If we try from here, if we choose from here, then what he will do? Okay, I will take this one. I will move to this flat, and then he have to move to the next flat. That is this one I will take since we have two different Pokemon so far. But when he goes this, he will try to take, but he cannot. I mean that he will choose, but this will not count in our answer. What I mean, since total four there are four different Pokemons you have to catch at all, but we have catch in three flats we have catch so far only two. So we need to find two more. So he will go with this, and then he will go with this. So this is also an answer, but this doesn't gives us the optimized, that is the minimum value so far. So what is the minimum value? So the minimum value is this one. Wait, yeah, this one. So we catch four. in four flats. So answer will be four rather than five or six. So answer will exist like the maximum answer that can be n. We need to find out the minimum. So how can we find the minimum so far? So first of all, let's see the test cases range. That is n. It's 10 to the power 5. So if we try to do in some brute force method, something like that in order of n square, then it will give us TLE. Since we know that online platforms doesn't support greater than 10 to the power 8. To be in safe limit, we have to be in lesser than 10 to the power 8. That is according to the situation, that is order of n log n, or something like that, but not order of n square at all. So, like, how can we think brute force? One of the misconception I have to solve for you. You can think like first flat, second flat, third flat, because this misconception is being with me. Like I solved this because I don't know, like this misconception may be with you. So I should tell you this. So let us suppose there are six flats, and you may think like, why not the answer just be the number of different Pokemons? That is, we can say like, let us suppose A, A, B, B, or maybe C. So we just output there are four of them. So there are four of the different Pokemons. So we can choose. You may think it in a subsequence way. Subsequence way. I know that because I think in that way. So maybe you may think, but I think that. So you may think like choosing this one and then choosing this one, choosing this one, choosing this one, choosing. Sorry, it's maybe five. Yeah. So the five according to will be answer. But the thing is that when he cannot choose like that. If he had first flat, then he cannot jump like fourth flat or directly to sixth flat. He has to move to the flats to the its consecutives. That is a sub array, I say so. Like if he had first flat, then he has to move to the second flat. He has to choose the second one if he wanted to choose. So like this is the number of flats that he will take up. So the answer will be for if you are going like that will be six. So it's not a subsequence. It's a sub array. So it's a contiguous thing first of all. And what do you think from the contiguous part? I think you may get the intuition behind that. That is sliding window. I know you are right. Why sliding window? First of all, maybe for someone may think like why sliding window at all. Sliding window is simply first of all why sliding window is useful. But like when sliding window is think like we can think for it. Let's suppose this is an island and we wait a second. And this is total sliding window we have taken. That is, this is the sliding window so far. If we have done this part, we know that this is our answer. Let us suppose this is our answer. But we can move to the minimum or maximum we have to choose so far. This one is the minimum. Sorry, this is one the answer that we got. And we don't know like this is maybe minimum or maximum we have to output. So what we think, what we do is to if we take this one, then answer like it is a monotonous. Monotonous mean things should be completely linear. I mean that let us suppose this is an array, this is an array, and this one is the sliding window. So far, if I remove this one, if I remove this one, then things should be a contiguous. Let us suppose one, two, three, and then four. If we choose this one, then our array will be to 1, 2, 3, 4. And if we try to move, then this one will be our sliding window. And this also shows the things like it also giving us the value. Uh, Let us suppose this satisfies some condition X. And if we try to if it and we have proved that if we try to think like minimum number of elements whose sum minimum number of elements whose sum let us suppose let's suppose is y. Okay, and y let maybe we can say six, and maybe we can say six, and let us suppose okay. So this one is three. Wait, this one is three. For easy for you like why sliding window is useful like why monotonous we say. Wait a second, just. Uh, I should be more clear with you, so that's why I'm doing that. Okay. So since so far we try to take this one and then this one, we get total sum 3 and we want more. So we will take this one. So 1 plus 2 plus 3 equal to 6. So this is our answer. So we will say that this sliding window is our answer and the answer is 3 because 3 element that we have chosen so far. But can we decrease? Can we decrease? I tried to decrease this one and the sum will become 5. So we cannot move. So we try to move further like this one. And sum becomes, what the sum will become? 6 plus 3 is equal to 9. So since 9 is greater than 6, we know that we cannot choose 9 at our answer. We try to decrease the window. Maybe some value that really gives us 6. So wait a second. Wait a second. Yeah. This one is a left pointer and right of this one is the right pointer. So we will take our right left pointer to the right. That is this. So total 9 minus 1 that is 8. Still greater. So we will try to decrease. 8 minus 2 that is 6. Again the same answer. So the, when you reach a condition, so when you reach a condition of a in sliding window, then if you try to decrease, then it should be monotonous. Like if we decrease, then it should be decrease. If we try to increase, then it should be increase. Not like we don't know about that. What if there is negative numbers? Because I also like you, maybe if you know about sliding window, but for me, it's something like I should know more. So, like here is positive value so far. I know I'm totally distracting with the question. I'm not solving the question because I want to tell more about sliding window because the approach here will use that. If you are okay, so you can see, or if you can, or if you know about sliding window more, so you can just skip out. Okay. So let us suppose this is positive and positive. So we know that if we move our left pointer, then value will definitely decrease. So we are sure. And if we try to take this right, if we try to move right pointer, we know that the value will always increase. So this is a monotonous behavior. And when monotonous behavior doesn't work, like here negative, here positive, here negative, we don't know about the values that we can get. Maybe that sliding window can be decreased or maybe. So we will try to take like maybe this one is the answer that we got. If we take this one positive, so it may increase from our condition. That is why. And you don't know about that because some values are increasing, some values and moving to the right and decreasing. So you don't know about where should I take our sliding window. So that's why monotonous behavior is needed in sliding window so far. So this is all about sliding window. I think you got it. And this one is this method will be used in this problem. So where we were at this part. It is A, B, and then C. So first of all, we will try from here. Since the monotonous behavior, because I will tell you. Okay, I will tell you. So we will start from this L equal to 0 and R equal to 0. So here we start. Since first of all, we have to find out how many different Pokemon so far. So we need to match with the condition in the sliding window. So there are total five different. We have to find out. You can use that or whatever its opponent. So first of all, we have find out that five different of them are present in this in our uh, in our flat. That is in our sorry in our string. Okay, I should add one more. Wait a second. From not from here. Wait. Yeah, I got a graphic tablet to help you more easier. I have bought. I think I bought it almost 1 year ago, but not used properly at all. So now it's useful for me. So I add one string. So since this will not change, okay. So L start from here and R start from here. So we will track the things. Okay. So total different we will calculate and answer we will calculate. Sliding we will calculate. Okay. And L and R is head here. Okay. So different so far is one. Okay. And then I will move forward. So what I will do is to take, wait a second. I should just now R equal to 1 and C and A. Two different so far. C, A, A. We will track things by map. Okay, so map, you should use map or whatever data structure. I think map is better. So it would be character of it. I don't know about Java and Python, sorry for that, but you made like hash map, you can say. We will try to hash map the things because I'm not into Java that much and Python, so sorry for that. Uh, for you, intuition is main. So, like you can say, like tracking, we are tracking. Okay, so C is one, A is one, small a is one. Okay, so total so far, we have two different, and then R we move to here. So R will be at two. So total three, and okay. Now we will move our R again since the condition didn't fill. That is five different. So wait a second. I should remove them because it may not. Then I put R at here. That is 0, 1, 2, 3. R equal to 3. Again different. Okay, so we will change the value and we will put B equal to 1. Again we move and R equal to 4. R becomes your 4. So again different. So total difference so far is 5 and B is equal to 1. So what is the length of this since we have met the conditions? The length is your 5 is your answer. Okay, 5 is your answer since so far. We don't know. We will try to show the minimum. Okay, so we got to know that like we have fulfilled the conditions so far, and this is the sliding window that we have find out. Now we have find out like now we will try to like can we decrease the sliding window or not? In this situation we cannot because five is the different type and five is the total Pokemon and five is the planets that we have to visit at all. But in other test cases you need to think you need to decrease. So we use sliding window. So what we will do? We will like can we increase again? So we will increase the thing. Okay. So total element so far is six, and different is same five. Now we will try to decrease. So we will take L equal to one at here, and first of all we check is the first character that L equal to zero. Is this your greater than two character frequency is greater than two or not? Since C since from here, wait a second, just uh, from here to here we are. This is our sliding window, and C is equal to 2. And if decreasing by 1, doesn't matter at all. So we will move L equal L at here. Okay. So can we increase our sliding window so far? No, it's just out of bounds. So what is the answer? So ANS equal to 5, we will repeat. We will put. This is the first test case. I will go with the second test case or more. I think this one may be good for you or this one. Wait, this one will be like more you will get to know about this problem, the intuition so far. So B C A C B C. Okay, so we are at here at L equal to 0, R equal to 0. Here our different we calculate, frequency that we calculate. So total different so far. You can not store total difference so far because if you are using map in C++ or I don't know about other about can we calculate the size or not, but you can track with total different that total difference so far. But in hash map of in C++ hash map or you can say map, we will can go with size. I will tell you why. So L equal to 0 and R equal to 0. I should like you should know about why I'm using size. So I'm going with total difference so far in that sliding window so that I should be more clear with everyone. Total different in sliding window. Wait, I know I'm just making things more messier. Wait a second. I know I'm making B C A C B C and here we are tracking. Wait a second. I know like you can watch this video in 1.5x. Because explaining the things itself take time so you can see it will be better for you. So total different total different in sliding window that we have taken. And the total different characters. Okay, I think I should seek upon my handwriting too. And hash map, or you can say frequency that we will store. Okay, so uh, L equal to 0. Oh, wait, L equal to 0 and R equal to 0 we are. So this one is the first character we are choosing. So total character, different character in our sliding window is 1. And total different characters so far in the whole flats, 1, 2, 3, and then I think 3. Yeah. Oh, sorry, 1, 2, 3. Yeah, 3. So total 3 different characters so far. Then we will move our R since we doesn't fulfill our condition. So R equal to 1 and B equal to 1, C equal to 1. And this one and total different factor in our sliding window is 2. Then we will move to A and then R equal to 2. And total different factor in our sliding window is 3 and A equal to 1. So what we will do in our ANS, since initially ANS is infinity, or you can say long max or whatever. So we are saying infinity. So ANS equal to minimum of what ANS is storing right now, comma L minus R plus 1. What is it? It's 3, comma NS, that is infinity. Which one is minimum? That is 3. So NS right now is 3. Sorry, the sliding window of ours. So we will try to move our sliding window more. So R equal to 3. Okay, capital A equal to 1. Can we decrease our, like, what is the frequency? Like, can we decrease our L or not? Not at all. Why I am saying not at all? Because B hash map, B's frequency is 1. B frequency is 1. If you try to decrease, then you will lose your condition at all. So you will, what you will do is to, okay, I will take this one too. You should have to maintain the condition. Okay, so A becomes 2 and total difference sliding window, the things, the things remain same. Again, we will try to pick up this at R equal to 4 and we will just, the same thing will happen and C will becomes 2. And this one will be our sliding window. This one will be now sliding window. Okay, I think you are getting because I'm explaining in totally in depth. Okay, I know you will get what I'm saying. And then we move to this, and then we will check. Uh, is can we decrease our sliding window or not? That is, can we decrease since B becomes 2? Can we decrease? Yeah, we can decrease. We will use a while loop. So we will try to decrease since B is greater than 2. We will decrease this one. So this sliding window, this one is not our sliding window now. This one. And then we again check, like, is C's frequency is greater than 2? Is it greater than 1? Yes. So this one is not, we will pick. Same with this will happen. And then again we comes up at here. Yeah, at here, or here L equal to 3. Wait a second, I just clear some part. Wait a second. Okay. So like where we reach. We reach at here, at wait, at this part. So ANS again becomes, we will try to track. ANS again becomes 3 and then, sorry, L equal to 3 and R equal to 5. Then we will try to increase our value and then just ANS equal to minimum of ANS comma L minus R plus 1 we will do, and you will get to know that here's our answer. So this is how we will do this problem. Like tracking, that is sliding window. And I also tell you why it is sliding window and why the question is demanding to use sliding window. So let's move to the code part. Okay. So first of all, wait. First of all, we will take the input int n string as we will then take, and then set why I'm using, because I wanted to know how many different characters so far. And then I will track, and then int st dot size will tell us different characters. Then int l equal to 0 map for track frequency storing int count you will wait a second. Okay, so count is like you are just L minus R plus 1, you can say. Nothing more than that. It's L minus R plus 1. So for and then n is equal to infinity. So int I equal to 0, I is less than n, where I is representing n. We will add the value and count plus plus if mp dot size at the situation that the condition we met, and if while mp of s of l is greater than 1 or not. Like that I have told you, like we will try to decrease our sliding window if we can decrease so far. So we will just do mp of sl minus minus count minus minus ans equal to minimum of ans comma count, and then we will add our l plus plus. And what we will do is ans equal to minimum of ns comma count. You can use say L minus R plus 1 for count. While and then again you will just do, because what will happen uh, after that wait a second, just actually okay, because I just paused the video and that's it. So where we were like wait a second, I will should tell you this one part. So here you can see that we reach at this position. What if this is CA CB? Let us suppose this is a condition. So we take this one, we take this one, we take this one, we take this one. So according to the situation, then answer equal to 4, but answer is not equal to 4. Answer is actually 3. So after doing this, we need to decrease our sliding window because we don't know, like we just is the condition, but we need to then again try to decrease. Okay, so that's why I again use for loop for that. That is while loop. That is, can we decrease sliding window so far or not? So that's why. Okay, so then again, we will do the same thing and n minus l that you know. Okay, so you can use count or r minus l plus 1, it's all upon you. Then we will just see out ns answer. I hope you will get this, like I explained the sliding window, and then why sliding window is useful for this question, everything in depth. Actually, I've never told everything in depth in previous videos, but I think I should go with that, and it will be helpful for me and also for you because I want to explain the things so that I can just wanted to. So that's from my side. And yeah, any issues, just post a comment, just put the comments of like, I don't understand this part or something, or if you wanted to say that do this question, I will do that question if I can able to, and I will put the video in the YouTube and will explain. So that's from my side. I hope you get the explanation and bye.